Assalamu alaikum everyone. Dear student, I hope you are fine and doing well. So today our class is fundamentally the about matrix decomposition. Uh, what does matrix decomposition means? It means how one can write any matrix as a combination of some other matrices. If you know about integer factorization problem, that any integer can be written as a product of prime or some product of other number. With this property, you can what you call investigate any integer, whether it is divisible by certain some uh, how any integer can be divisible by some other numbers. So same in the case of matrix decomposition. How one can decompose any matrix into a upper half, lower half, or you can say orthogonal matrices, or you can say with as a symmetrical, or you can say as a combination of diagonal matrices. So let the idea of our last chapter, I mean to say the matrix decomposition. First of all, we must realize what does matrix decomposition means. And so that is why I'm going to teach you today the about matrix decomposition. It is quite important because there are a number of decomposition problem in digital multimedia and digital medium, or you can say in a digital medium, or you can say in a computer vision. So one of the very important, or one of the very useful problem of matrix decomposition is singular value decomposition. Through singular decomposition, you can compress any digital medium. It may be satellite images, it may be any image. So you can save your what you call the memory on some machine, like on PC and something like that. So, dear student, that is why I'm going to teach you the matrix decomposition. So, not just like why we are going to calculate the eigenvalues and eigenvectors. So, eigenvalues and eigenvectors are also important because the eigenvalue decomposition problem is also based on eigenvalues and eigenvectors. So, let me firstly elaborate the idea of matrix decomposition, and then we will discuss eigenvalues, eigenvectors in a detail. So there are fundamentally two to three types of decomposition. Matrix decomposition, it based on order of matrix. If order of matrix is, you can say if the matrix is square matrix, then it has some different decomposition. If matrix is rectangular, then it has some other different decomposition. So let me explain this with the help of some integer factorization first, then we will elaborate this in on matrix decomposition. A need of decomposition or need of factorization, let us elaborate this with the help of one very simple example. If you want to discover the nature of something, the decomposition is an efficient and practical approach. Let us say if you want made some new friend, and you want to know him about him or her, so you have to decompose his with respect to some qualities, like his view about the existing world, his career, his hobbies, or his connection, or you can say this. So you basically divide the person which is your new friend into four categories, and you can basically decompose this this new friend with respect to its some qualities. So This is the decomposition. So that is why we need some decomposition, because we want to analyze certain characteristics of some phenomena with respect to certain other parameters. So this is one of the way that how why we need decomposition or factorization of something with respect to some other parameters. So let us first play with some integers decomposition or factorization. Let us say you have a one integer, say 20. It can be the 2 into 10. It can also be written as 2 into 2 into 5. It can also be written as 4 into 5. It can also be written as 20 under root 20 into under root 20. Or it is also 20 into inverse of 20. It is equal to identity. So dear student, from here, one number have some different factorization or some different decomposition. Same in what you call from this factorization or decomposition. This is quite you can see from this calculation that 20 from this calculation you can see this this means 20 there is no factor of 20 which is divisible by 3. So one can say the multiple of 20 is 2. It may be some other factorization is also possible. So 2, 5, 4, and you can say 1. These are all basically factors of 20. So from here you can see there is no factor. So you can say there is no factor of 20. I mean to say 3 or 7, or you can say 9, 11. These are not what you call the factors of 20. So you can see one number which is 20 has some different factorization or different decomposition. So same is the case in matrix algebra. There are different types of matrix decomposition. How you can decompose any square matrix, how you can decompose any rectangular matrix into some other types of matrices. Say, let me elaborate three types of decomposition which are based on square matrix, and two other what you call the matrix decomposition which are based on rectangular matrices. So the first one is eigenvalue decomposition. If you have say square matrix was eigenvectors are linearly independent, then A can be decomposed as A into V uh, lambda V inverse, or A equal to V diagonal lambda into V inverse. So if you can say this sign, which is sometimes we call it as a lambda, or you can say it's big lambda, is the diagonal matrix whose diagonalities are the eigenvalues of A. If you can see over here, the if you can elaborate this with the help of some this diagram, A is any square matrix, and this is basically eigenvector. V is the eigenvector of A, and these are eigenvalues of A, and this is V inverse is basically the inverse of this eigenvalues of A. Basically, you can take the inverse of this matrix. In that case, if you can multiply these, you will get back A. Or you can say A can be decomposed into eigenvectors, eigen matrix of eigenvalues, and inverse of uh, inverse matrix of eigenvalues of A. So in that case, we can say this is the eigenvalue decomposition. Here you can say A can be decomposed into three further matrices. Uh, like this one. If you have original matrix, this is the eigen vectors. This is diagonal matrix, which is consists of eigenvalues matrix, and this is inverse of this one. So in that case, this is just a elaboration. Identity decomposition, that is, identity can be written as what you call a into a inverse or a inverse into a. This is also decomposition of a square matrix. Cholesky decomposition, if you have any symmetric matrix in which a matrix is a symmetric if A is equal to A transpose, or positive definite if U transpose A into U is greater than U transpose I means to say eigen vector of transpose of eigenvector of A uh, time A into U is greater than 0, then in this case, U can be written as a combination of decomposition of L into L transpose, where L is lower triangular matrix with positive diagonal element, and L transpose, basically L of T is the transpose of this L. So in that case, you can see over here, this is another decomposition that A can be written as L into L transpose. LU, or triangular decomposition. So if you have any matrix A, it can be written as a lower into upper triangular matrix. This is also matrix decomposition for square matrix. QR factorization, the QR factorization is fundamentally used for what you call the rectangular matrix. The QR decomposition is fundamentally the matrix where A can be written as Q to R, where Q is M cross N matrix with Q into Q transpose is identity. If any matrix that satisfies this property, where Q into Q transpose is identity, in that case we can say Q is the orthogonal matrix. So A can be written as an orthogonal as well as upper triangular matrix R. This R is upper triangular matrix, square upper triangular matrix. So in QR decomposition, A can be written as a orthogonal. A can be written as a orthogonal matrix into upper triangular matrix. SVD, singular value decomposition, it's another very important matrix decomposition. We call it SVD, singular value decomposition. It's also very useful for a rectangular matrix. Like A can be written as a U sigma into V transpose. Here, if you can look over here, U is in case of real, this is orthogonal matrix. But in case if I can take it any matrix whose element can be from any set, then it is a unitary matrix. If I can generalize this, the entries can also be from complex number. In that case, you use the unitary matrix. So in our course, we are just deal with the real matrices, because the element of matrices are from real numbers. So the in that case use a orthogonal matrix of M cross M. So sigma is the rectangular matrix of whose diagonal are M cross N matrix with diagonal entries are non-negative D1. These are belongs to sigma, because these are arranged in the descending order. V is another orthogonal matrix of square type. So SVD fundamentally is used in image compression and computer vision. So let me elaborate this with the help of one diagram. Here you can see over here, A can be written as U times sigma into V transpose. This is right singular vectors, this is singular values, or this U is left singular vector. Or it can also be written as A is M cross N matrix, then A can be written as orthogonal into diagonal into orthogonal matrix. So A is U into summation sigma and the V transpose. So, dear student, these are our today lecture. So, in next class, we will discuss how we can perform these decomposition. First of all, we must know why we are going to start this chapter. This chapter is fundamentally based on matrix decomposition. You must keep this thing in your mind, as any number can be decomposed into product of uh, different numbers, as I have discussed in integer factorization decomposition. Say I have discussed 20 as example, and 20 the possible combination of 20 as a product of other number. It's not just one decomposition in case of number. So similarly, in case of matrix, there are more than one decomposition. A matrix A, it depends upon order of a matrix, and also A can be written in a several ways of it can be decomposed into different decomposition. I just celebrate the five of them. There are other decomposition are also available, but we will focus on these five decomposition, which are quite useful. And one of our course project, which is based upon SVDs, are also based on this decomposition matrix decomposition or singular value decomposition. Yes, student, let us sum up. Basically, we are going to start a chapter that basically give us the idea how to perform decomposition of a matrix into several other matrices. So till then, these are some resources. Till then, Allah Hafiz. Thank you all, and please stay at home. May Allah bless you all. Allah Hafiz.